Welcome to Naradar Academy. In this video, we are going to do a few problems using Stokes theorem. The statement is, if S is a surface bounded by a simple closed curve C, then integral over C A vector dot dr vector is equal to double integral over S del cross A vector dot ds. That is, here S is the surface and C is the boundary of that surface, and A vector is a vector valued function which is defined on S, and this has continuous derivatives in the surface. So A dot dr is equal to double integral del cross A vector. Del cross A vector is nothing but curl of A dot product with ds. So here what does this mean? The value of A summed up the curve. C is the curve, no, boundary curve. The value of A taken over throughout the curve C is equal to, this is nothing but curl of A vector throughout the surface S. Let's do few problems based on the Stokes theorem. The first problem, evaluate integral over C A dot dr for A equal to 2x minus y I cap minus y z square j cap minus y square z k cap taken over the upper half surface of the sphere x square plus y square plus z square equal to 1, z greater than 0, and boundary curve C, the circle x square plus y square equal to 1, z equal to 0. See, this is the function, vector valued function, which is defined over the surface S. S is the sphere, unit sphere. X square plus y square plus z square 1 is there, no? So 1 is the radius. So this is called unit sphere, and we are not taking the whole sphere. We are taking only the upper half of the sphere where z is greater than 0. That means only half of the sphere where z is positive. That part only we are taking. So hemisphere means it will be bounded by the circle only, no? That is, on the top of the sphere, what will you be having? Only the circle, no? That circle equation is given here. That is, see. So this is the sphere, hemisphere, and this curve is the circle. Always whenever you cut a sphere into two parts, the boundary will be what? Circle. So this is the surface, x square plus y square plus z square equal to 1, and this is the boundary, x square plus y square equal to 1, boundary curve C. And which part of the sphere we have taken? One more part will be there, no? So two parts are there. That is because it's a hemisphere, no? Two parts are there. We are taking only the part for which z is positive. That is, this is along the positive z axis. Here below this z will be negative. So we are not taking this part. Only the positive part of z we have taken. So we have to evaluate integral over C A dot dr. For evaluating this, we are going to use Stokes theorem. So what is the statement? By Stokes theorem, integral over C A dot dr is equal to double integral over S del cross A dot ds. So first let's find what is del cross A. Now here del cross A dot with ds, no? This ds is the surface integral, and this S will be written as a bold letter here. So for removing this, that is for eliminating this ds, we have to write it like del cross A dot n cap with ds. Okay, where this ds denote a small elementary area of the surface. Okay, so this can further be written as del cross A dot n cap ds. This n cap is the unit normal drawn outwards from the surface. Normal means what? Perpendicular. Unit normal means perpendicular normal with modulus equal to 1. So this is the unit normal of the surface which is drawn outwards. Here whenever we take normal, it has to be taken only outside. You will never take normal in the inward direction. It will be always in the outward direction only. Okay, so this is the statement of Stokes theorem. So we are going to evaluate this, that is del cross A. So how will you find del cross A? Cross product. So del cross A equal to determinant. The first row will be I, j, k unit vectors. The second row, components of del. Components of del are dou by dou x, dou by dou y, dou by dou z. and the third row components of A. 2x minus, this is given in the question, no? 2x minus y z square minus y square z. So I cap into, how will you expand this determinant? Plus minus plus, okay, I cap into, leave this row and this column, the remaining determinant, dou by dou y, dou by dou z minus y z square minus y square z. Next one is minus j cap into, leave this row and this column, dou by dou x, dou by dou z, 2x minus y square z, plus k cap into, leave this row and this column, this determinant, dou by dou x, dou by dou y, 2x minus y into, 2x minus y and minus y square z. Now let's expand these determinants. So how will you expand? This side minus this side. So here look at this, dou by dou y of this, that is differentiate this with respect to y. So what will you get? Y square is 2y, no? So 2y minus 2y z minus this product. So here dou by dou z of this one. So differentiate with respect to z. So minus 2y z. So minus 2y z minus of minus 2y z. So it will be 0. Next here minus j cap into dou by dou x of this. So differentiation of this with respect to x is 0 because no x term here, and here differentiation of this with respect to z. No z term here. So this is also 0 plus k cap into here this one. So differentiation of this one with respect to x. So there is no x term. So it will be 0 minus dou by dou y of this. Differentiation of this with respect to y. So 0 minus 1. So 0 minus 1, that is minus of minus will be plus. So all the terms are becoming 0 except this. So k cap into 1 we are having. So del cross A equal to k cap. So the first step, we found out the value of del cross A. Next we have to find what is this n cap. This n cap I told you, no, this is the unit normal drawn outwards to the surface. So for that given surface we are finding the unit normal. So let us take the surface equation. What is the surface equation here? X square plus y square plus z square equal to 1. That is sphere equation, no? Whether it is hemisphere or the whole sphere, you don't bother about anything, just you take the equation of the sphere. X square plus y square plus z square equal to 1. You bring that 1 to the left hand side and keep the right hand side 0. So x square plus y square plus z square minus 1 equal to 0. This is taken as phi, the scalar point function phi. Now n cap is given by del phi by modulus del phi. So this is the unit normal drawn outwards for any scalar function phi. Okay, so let's find del phi. Del phi equal to, how will you find del phi? I cap into differentiation of differentiation of phi with respect to x. Differentiate this with respect to x, the entire function. What will you get? 2x. So I cap into 2x plus j cap into differentiate again phi with respect to y. So all the terms become 0. Only this term will come, that will be 2y plus k cap into, again this one will become 2z. K cap into 2z is equal to what? Take 2 outside. 2 into xi plus yj plus zk. Okay, but xi plus yj plus zk, this is what del phi. Next we have to find modulus del phi for the denominator. We have to find the unit vector, no? Unit vector is obtained by dividing a vector by its modulus. So modulus of this vector is equal to square root of this 2 square is 4 into I component square is x square plus j component square is y square plus k component square is z square. So square root of x square plus y square plus z square. But what is the surface equation? Sphere. That is x square plus y square plus z square equal to 1 throughout the surface. So here also we are getting the same x square plus y square plus z square. So replace this by 1. So it will be square root of 4 alone. So it's equal to 2. So what is n cap? Del phi, 2 into xi plus yj plus zk by 2. 2 get cancelled. So xi plus yj plus zk. So del phi by modulus del phi is the value of n cap. Next, let's find what is del cross A dot product with n cap. Del cross A dot product with n cap is equal to, here only k vector is there. Here xi plus yj plus zk. For dot product, what you have to do? I with I, j with j plus k with k. But here I component, j component are not there. That means they are 0. Only k component is there. That is, k component coefficient is 1. So del cross A dot product with n will be 1 into this z. 1 into z is z. So this is what we are going to integrate. So let us take this as 1. So next one is we have to replace the ds is there in the integral, no? The ds has to be replaced. For replacing this ds, we have three different things. One is ds can be dx dy by n dot k cap, or dy dz by n dot I cap, or dz dx by n dot g. We can take any one of this depending on the problem. For this problem, we have given that the boundary of the circle, the boundary is the circle x square plus y square equal to 1. That means it is on the xy plane. No z term is there, no? That means what? Z equal to 0. Z equal to 0 means it represents xy plane. So when you take the projection is on xy plane, you have to take this one only, dx dy. So integrate with respect to x and y, divided by n cap dot k cap. What is this n dot k? See, this n is the unit normal to the surface. Okay, at any point of the surface, if you draw a perpendicular, that is n cap. This k cap is the projection is there, no? We are projecting it on the some plane, xy plane. For xy plane, what is the standard normal? Xy plane, z axis is the normal. Z axis means what? K cap. So k cap is the normal. So that k cap, we take the dot product of surface normal and the planes normal. Okay, so the surface unit normal is called n cap. We are taking dot product with normal of the plane in which you are projecting the surface. Okay, this is because we are projecting that surface on the xy plane, no? On a plane area, no? So for that we are writing this term. Okay, in the same way, if you are doing it on YYZ plane, where is YYZ plane? This is YYZ plane. Suppose if another problem you are projecting it on YYZ plane, it will be n cap dot product with I cap. For YYZ plane, x axis is the normal. For x, we have to take I cap. In the same way, for projecting it on XYZ plane, here XYZ plane means y axis is the normal, unit normal, that is nothing but j cap. Okay, right. So for this particular problem, we are going to take only this alone, because the question itself they have given x square plus y square equal to 1 is the boundary circle, right? So let us substitute all these values in the given integral. So double integral over del cross A dot n cap ds is equal to, this is n z we have found out. So z into dx dy by n dot k. Okay, so z into dx dy by n cap is what? N cap is equal to z and k z dot product with k. So it will be equal to what? Z only. So here it will be modulus z. But modulus z means what? Only the positive value we will be taking. Again in the same question, they have given z is always positive for this problem. So instead of modulus z, I can simply write it as z. So this z and z will get cancelled. So we are getting double integral over s dx dy. So whenever you get double integral over s dx dy without any other functions here, this will simply represent area of the given region. So here the given region is what? X square plus y square equal to 1. So this is nothing but circle. Its area is pi r square. Here the radius is equal to 1. So pi into 1 square equal to pi. This is the next problem. Evaluate integral over C a dot dr where a equal to x square I plus xyj taken over the square surface S in the xy plane whose vertices are 0, 0, 0, a 0, 0, a 0, 0, sorry, a 0, 0, a 0 and over its boundary. So here a vector valued function is given, and this we are going to integrate through the surface of the square. The four vertices of the square are given here. Okay, now let's find, we are going to use Stokes theorem here. Let's find del cross A. So del cross A equal to, as usual, the unit vectors I, j, k in the first row, components of this del in the second row, dou by dou x, dou by dou y, dou by dou z, and components of A in the last row. Components of A are x square and xy, no I component here, so it will be 0. Why there is no I component here? Because this is taken in the xy plane, no? Whenever you are taking any point in the xy plane, there the value of z will be 0. So no z term here. Also k component is absent there. Okay, so x square xy is 0. Now I cap into, leave this row and this column, this will alone come, that is dou by dou y, dou by dou z, xy 0 minus j cap into, leave this row and this column, dou by dou x, dou by dou z, x square 0 plus k cap into, leave this row and column, dou by dou x, dou by dou y, x square xy. So let's expand this determinant. This is 0 because 0 here, no. Next, this one, differentiate this with respect to z. So if you differentiate with respect to z, again 0 minus j cap into 0 minus 0 because dou by dou z is there, no. Differentiation with respect to z is 0 plus k cap into differentiation of this with respect to what, x. So it will be y only minus differentiation of x square with respect to y is 0. So finally what you get, del cross A equal to y k cap. That's all. Next, the given surface is a square, no. Let's draw the square. What are the points given here? First one is origin, another one is A along the x-axis because y and z are 0, no. So A unit along x-axis and this is A unit along y-axis and this is the point in the xy plane. Okay, so 0 0 0, this is along x-axis take A unit, along y-axis take A units, then join the two lines, this will be the next point, that is A 0 on the xy plane. So this is the square. Now we want to find n cap. In the previous problem, n cap we find using the formula del phi by modulus del phi because there it is a surface, curved surface, no. For that you have to find in that way only. But here this is lying on the plane. So no need to compute del phi by modulus del phi and all. It is simple. You see, look at this picture. This is the xy plane. So what is its perpendicular? Throughout the square, this z-axis is the normal. That means k is the unit normal. That is n cap is equal to k cap. Because this is a plane area, no. For usually for plane areas like this, square, rectangle, cube, cuboid, if anything is given like that, you cannot you need not to find del phi by modulus del phi. Just you look at the plane where it is lying. So for that plane, you will be having standard unit normal, no, either I, j or k. So that one alone you have to take. No need to go for del phi by modulus del phi calculations. So here n cap is equal to k cap. Suppose if your square is lying here in this particular octant, then it will be I cap. If in this octant it is lying, it will be j cap. So depending on where it is, that plane area is lying, you have to choose n cap for plane areas. So here it is k cap. So del cross A dot with n cap is equal to, already it is y k cap, dot product with k cap, it is equal to simply y. Next ds. ds is equal to, again this problem is also, it is lying on xy plane. So we have to take dx dy by n dot k. So dx dy by n is also k only, k dot k is equal to 1. So simply dx dy. So integral over c a dot dr equal to double integral over s dx dy into y. Now, so here we are having y into dx dy. So this you can go by the regular integration or simply you can write this as y bar into a. What is this y bar? Y bar is the y coordinate of center of mass of the given square. Okay, find the center of mass and find the y coordinate, that is y bar, and a is the area of the area of the square given here. Okay, now area of the square is what? A square, because here each side is of length a units, no. So area of the square is equal to a square. Next to y bar, that is center of mass. This is a square, so center of mass will be lying at the point where the midpoints of each side is joining. So what is the midpoint along x-axis? This is of length a, no. So it is a by 2. For y-axis also length a, so the midpoint is a by 2. So a by 2 comma a by 2 is the center of mass. We are taking only y coordinate, so it is a by 2. Substitute here, a by 2 into a square equal to a cube by 2. One more problem. Evaluate integral over c a dot dr where a equal to xy I cap plus yz j cap plus zx k cap taken over the triangular surface. This is a triangle, okay, given here. S in the plane, x plus y plus z equal to 1, bounded by the planes x equal to 0, y equal to 0, z equal to 0 and over its boundary. So this is a triangle which is the region given here, we are going to evaluate the integral over there. So we are going to use Stokes theorem. Integral over C A dot dr equal to del cross A dot n cap into ds. So del cross A equal to I j k dou x dou y dou z. First row unit vectors, second row components of this del dou by dou x dou by dou y dou by z. Next row components of A, x y y z and zx. So expand this I cap into, leave this row and this column, it will be dou by dou y dou by dou z y z zx minus j cap into dou by dou x dou by dou z x y zx plus k cap into dou by dou x dou by dou y x y y z. So I cap into differentiation with respect to y is 0. Here differentiation with respect to z is y. Minus j cap into, this is differentiation with respect to x. So z minus differentiation with respect to z is 0. Plus k cap into differentiation with respect to x 0. Minus differentiation with respect to y is x. So it's simply minus y I cap minus z j cap minus x k cap. So this is del cross A. Next, what is the surface given here? X plus y plus z. So this has to be taken as phi, and we are going to find the unit normal drawn outwards for this surface. So for that we have to find del phi by modulus del phi. Bring all the terms to the left hand side. It will be x plus y plus z minus 1. So let's find del phi. Del phi is nothing but I cap into differentiation of phi, the entire phi with respect to x. So it will be 1 only. So I cap plus j cap into differentiation of phi with respect to y. So 1 plus k cap into differentiation of phi with respect to z 1. So this is I plus j plus k. Modulus del phi equal to square root of I component square is 1 plus j component square is 1 plus k component square is 1. So it's equal to root 3. So n cap equal to del phi by mod del phi equal to I plus j plus k by root 3. Next, del cross A dot n cap equal to, so this is del cross A note, take dot product with this n cap. Dot product means what you have to do, that is I multiply I component with I component, j component with j component, k component with k component. Here this minus 1 by 3 is a number which we can keep outside, into here y into 1 y plus z into 1 z plus x into 1 equal to x. Okay, but in the question what is the surface given here? X plus y plus z equal to 1. So here also we are getting x plus y plus z only. So instead of this term we can replace it by 1. So simply del cross A dot n cap equal to minus 1 by root 3. Next ds we have to find out. So let us project it on xy plane. We can do it on any plane, but let us take this be projected on xy plane. So it will be dx dy by n dot k. Why this k? Because we are projecting it on xy plane. So z axis is the normal, unit normal. So the corresponding unit vector is k cap. So n dot k, it is equal to dx dy by n dot k. What is n? This is n. K is k alone, k vector alone. So I j, here k only is there. So it will be what? 1 by root 3. So it is equal to root 3 dx dy. So integral over C A dot dr is equal to double integral over r minus 1 by root 3 into root 3 dx dy. Root 3 get cancelled. So minus integral double integral over r dx dy. So when you have dx dy alone, it represents area of the given surface. Okay. So this is a triangle. So area of the triangle. Area of the triangle is given by half into base into height. Here this is a triangle with vertices 1 0 0 0 1 0 0 0 1. So that means base is 1 and height is also 1 unit. So it's equal to 1 into 1. So what's the final answer? Minus half. That's all. Thank you.